Good morning, all. Am I audible clearly?
Yeah, you are audible.
Okay, thank you, ma'am. So good morning and welcome all, our esteemed speakers, our respected Jigyasa noodles and scientists of CSIR, and dear students, I wish you all a very happy and prosperous new year. So as you all know, that Jigyasa is a program launched by CSIR in 2017 with an aim to inculcate the culture of inquisitiveness and scientific temper among the school students. Till date, more than 5,50,000 students and 5,000 teachers have benefited from the program. This year, we are coming up with a new challenge under Jigyasa named as CSIR Jigyasa Epic Hackathon, Vigyan Se Viksit Bharat. This program envisages providing a platform to the budding student scientists to pursue their innovation and developing novel ideas under the mentorship of CSIR scientists. Today, we all have gathered here to launch the Span India competition. Now, I would like to call upon Dr. Geeta Vani Raisam, Head HRDG, to talk about CSIR Jigyasa and deliver the opening remarks. Now, to brief about ma'am, she has vast experience in academia, industry, government of India, and abroad. She's a PhD in biochemistry from IISc Bangalore and has postdoctoral experience in IGBMC France and at the NIH US. She has worked in industries such as Ranbaxy and smart analyst in areas of new drug discovery and development. She has been at CSIR for more than a decade in a variety of roles, ranging from open source drug discovery program to heading business development and industry alliance at CSIR IGIB. Now, she is scientist H and heading HRDG since last 2 years. Over to you, ma'am.
Yeah, good morning and thank you, Raina, for the long introduction. And so firstly, I would like to thank all our distinguished guests, Dr. Rishikesha Krishnan from IIM Bangalore, Dr. Radha from CDRI, and Dr. Ramanuj, who is the director of CSR IIM Tiboneshwar. And I'm very delighted to be here today, where we are going to launch this Jigyasa Epic Hackathon. As already pointed out by Raina, so this program was initiated in 2017 with the idea that school students can get a chance to interact with the scientists. So even earlier, people used to come to CSIR labs on an open day when the foundation day, but this is a much more tailored program. And throughout the year, the students have opportunities to visit the CSIR labs and actually interact and spend time. It could be a day, it could be a short-term stay also. Some of the labs do that. So that's been the USP of this program. And as Raina pointed out, even during COVID, we moved into online mode. So we continued these activities. And all this has been possible because of the variety of partners and the 37 CSIR labs working. So given the diversity of CSIR, it's a great opportunity for students in India to actually, if they're interested in aerospace, they can go to NIL Bangalore. They want to drugs, they can go to IICT or CDRI, so on and so forth. So this is a great opportunity for the school students and those who are joining today, both online and offline. I would request them to utilize this opportunity because we are in 22 states. So whichever state is closer to you and whichever place, you can always, visit the CSIR labs and get an opportunity to, see what the scientists are doing behind the four walls. Because mostly you read in textbooks about experiments, but you do not know what a scientist looks like and how do they work and what is actually experimentation and data and so on and so forth. So now coming to the Jigyasa Epic Hackathon, why this hackathon? So one of the things is, I always feel we tell our students, you come up with innovation, you come up, but then we teach them in a routine manner from the books and the CBSE syllabus or whatever syllabus. But we never give them an opportunity to really think beyond and come up with novel ideas. So in 2022, we organized something called as Jigyasa Vigyan Mahotsav as a part of Azadi Ka Amrit Mahotsav. There, the competition was just to get an idea and put it in a creative way through a video or a comic. So that was at the idea stage. So we say, can we go beyond just ideas now, So that is why this competition is now first to get the ideas from the students, especially in problems which are, pertinent to the country. And this time we chose two problems because energy, of course, clean and green energy is a very great theme given the sustainable development and the importance to the country. And the second topic was this One Health. where you talk about antimicrobial resistance and so many. Health is another major area. So we chose these two things because science is very vast. So we thought we'll restrict ourselves to two themes every year. And so these are the two themes we have chosen. And the modus operandi would be that we invite all over India for 1 month. The portal will be open, which has been developed in partnership with IIT Bombay, with whom we have a long-standing partnership for the Jigyasa. So this will be, the students can submit their ideas on the portal. And once the ideas are submitted, we will have experts to look at these ideas. And now the idea could be, can I come up with some small prototype of a device, or it could be an app, or it could be, or any other modes of ideas they have. And not just idea, the next step is actually once you pick the top 100, you associate them with a suitable CSIR lab. As I said, CSIR labs are wide and diverse. And so these students can actually spend a couple of months in summer vacation in the May to August or something, and then actually refine their ideas, and wherever help is needed, the CSIR labs will pitch in and actually come up with something tangible. Not that they may be successful, they may not be successful, but the idea is to hone the innovation. And then at the end of it, we plan to actually call some of the something like a Shark Tank, not really Shark Tank, but something where you actually have the students present their ideas to some of the industries or the innovation centers or the incubation centers, and then it gives them an experience. And then maybe if top 5, if we get some corporate social responsibility funding, we may even give them cash prize, or at least recognize them. So that's the whole idea of this hackathon, and to promote the innovation spirit and kind of guide them towards entrepreneurship, because I think we all focus on teaching, but hands-on experience is very limited. And this is our this pilot, one round of it was done by IITR Lucknow. So we thought, okay, the one lab was doing it, why not make it at a nation level? And so there are various dates. So we plan to culminate in September, and with the internship will be in May to August, and then September is where we plan to this. And as a part of this also, although we are launching today, our idea is every week we kind of have a boot camp in the sense, talk about this topic so that students also get aware by the experts, who talk about these areas. What does One Health mean? What are the possible areas of innovation? So students also get ideas, what should they work on? And similarly for health and for energy also. And apart from these two, we also want to get innovation experts. Like today we have Professor Rishikesha Krishnan, and every week we plan to have one person who talks about innovation and how innovation can be taught. So whether the students participate or not, this is also an opportunity for them to learn about these topics and innovation. So that's the whole thought process behind this hackathon. And now and again, I thank all the guests and also the students and our speakers today for being with us. And thank you so much.
Thank you, ma'am, for your remarks and giving an overview about EPIC Hackathon program. Now, I would like to call upon Professor Rishikesha Krishnan, Director, IIM Bangalore. Good morning, sir. We welcome you here.
Good morning.
So, to brief about sir, he has more than 140 publications spanning outlets that include referee journals, the popular press, case studies, book chapters, and books. These include 2 books on innovation from Jugaad Systematic Innovation, The Challenge for India, published in February 2010, and 8 Steps to Innovation, going from Jugaad to Excellence in 2013. The latter won the Best Book Award 2013-2014 from the Indian Society of Training and Development. So now I request Professor Krishnan to please inaugurate our EPIC portal.
Yeah, I'm happy to launch the Jigyasa EPIC Hackathon. Can we just go ahead and launch the portal, please?
ऐसा है कि मेरे को एक वीक का एक पैराग्राफ में जो हमारा डिस्क्रिप्शन वर्क है वो थोड़ा सा
Thank you, sir. Now I would also like to request you to please deliver your keynote lecture. Over to you, sir.
Yeah, thank you. Thanks for inviting me to this important event. It's indeed a pleasure to be part of this Epic Hackathon launch. And I would like to compliment CSIR on this important initiative because it's very important to get all the students involved with innovation in the country. And that will hopefully improve and deepen the innovation capability in the country, which is something very important if we want to proceed towards achieving the goal of Vikasit Bharat by 2047. So today what I'm going to speak about is about what it takes to be excellent in innovation. And I'm going to give you several examples, and I'm also going to give you some advice as students on what you need to do if you want to be a good innovator across your career. Just I would mention at the outset that innovation is not a one-time activity. This is something that you should cultivate as an ability which you can use throughout your life. So I want to just start with a small story. This gentleman is Dr. V, as he was popularly called. And he spent his lifetime in the Tamil Nadu government health service. But at the end of his career in the government, he was a little unhappy that the government health system was not able to provide visual healthcare as good as it possibly could. So after retirement, he decided to try and address this problem himself. And he set up what has today become a very famous eye hospital called Arvind Eye Hospital in Madurai. Now, he took up a very interesting challenge. The challenge he took up was that there are lots of people in India, particularly older people, who have what you call unnecessary blindness. What do you mean by unnecessary blindness? They have lost their vision, or their vision has got impaired because they have cataract. And as many of you kids would know, the cataract is something which is easily curable. It is a very simple surgery. It's a very low risk surgery, in fact. But if you look at the challenge when Dr. V first looked at this problem, he realized that a typical doctor or surgeon was able to do just 5 or 6 surgeries per day. And because the doctor's time was quite expensive and the doctors had limited time, it meant that per operation, the cost was quite high. And this was becoming a major barrier or obstacle to more people getting cataract surgery. So his problem was, how do you reduce the cost of the cataract surgery so that more people can overcome this unnecessary blindness? So just keep this problem in mind because we're going to come back to this in a little while. Now, one important question we need to ask is, how do you start on the process of doing successful innovation? And I would argue with you that a very important starting point is to choose the right problem to work on. Now, of course, you would immediately ask a question, how do I know whether a problem is the right problem or not? So let me give you a few examples, and then I'll also give you some framework to decide whether a problem is the right problem or not. So you would all remember that just a few years ago during the COVID pandemic, we had a sudden problem where many people needed to be admitted to intensive care units in hospitals. But at the same time, the ICU capacity across the country was quite limited. And there was a huge backlog of patients and people were getting badly affected due to this. Now, one company which was able to step in and provide useful support in this context was a startup in Bangalore called Cloud Physician. What does Cloud Physician do? Cloud Physician basically has been trying to address this whole problem of how do you enhance ICU capability and capacity in a situation where there are limited number of intensivists. Intensivists are specialists who can manage and run an ICU effectively. And the solution they came up with is to use telemedicine so that you can remotely manage an ICU so that even if a hospital does not have a trained intensivist, they can still use the ICU effectively and safely. So the problem was basically lack of availability of critical care personnel, insufficient utilization of ICU infrastructure because there were not enough specialists available, and as a result, an inability to deliver quality care, and of course would also lead to medical and diagnostic errors leading to missed treatment opportunities. Interestingly, in a similar space, there was another startup which looked at this problem in a slightly different way. There was a startup created by two young graduates from IIT Indore called Dozy. And they, in fact, started with a very different problem. They started with a problem of trying to help patients with sleep apnea. Sleep apnea is essentially a sleep condition where you don't sleep properly due to various reasons. And they had tried to create a way of monitoring the sleep to figure out whether you have sleep apnea or not within a non-invasive way. So they had created a sensor sheet which could be placed under the mattress, and it would observe your sleeping pattern and figure out whether you had sleep apnea or not. Now, they had a very interesting idea during COVID. They had the idea that this same technology which they had created to address sleep apnea could also be used to continuously monitor the vital parameters of patients. And that was, again, one of the important things that was required, particularly in the case of patients who were suffering from COVID and needed to be monitored on a continuous basis. So I hope you are getting some idea now about what a right problem is. I'm going to give you a third example. Some years ago, I interacted with a company called Vigyan Labs. Vigyan Labs is at that time was a startup based in Mysore. And the founder of Vigyan Labs, he identified a very interesting problem. The problem he identified is that today a lot of computing is shifting to the cloud. Essentially, it's shifting to huge servers or server banks, which run most of the big applications that all of us use online. And these data centers generate huge amounts of heat. And because they generate huge amounts of heat, they need lots of cooling. And as a result, they were guzzling huge amounts of electricity. And what Vigyan Labs found was that these data centers might be wasting as much as 30% of the electricity they pull off the grid, because many times not all the processors were operating, and maybe you didn't need all the processors to be working at the same time. So essentially what the Vigyan Lab team found was that there was a pain point. The power demand was shooting up because of this air conditioning requirement. There was a wave or a trend, that is, a lot of the computing was shifting to the cloud, to these data centers. And of course, there was a huge waste issue that about 90% or more of the electricity they pulled off the grid was getting wasted. So this is what inspired Vigyan Labs to come up with a solution to manage the power consumption in data centers in a better way. So I've given you three examples. Two of them are from health. One of them is from energy and environment. Essentially the two themes of your CSIR hackathon today, which show where entrepreneurs identified very clearly what is a problem that needs to be addressed. And then they went about finding an innovative solution to address this problem. So the key takeaway from this is there are three things you might like to keep in mind when you're looking for an interesting problem to solve. Does it represent a pain point, or does it represent a problem, obstacle, barrier that somebody is facing? Does it represent a wave or a trend? And does it also reflect waste? Waste could be of energy, could be of material, could be of human effort, whatever kind of waste. Whenever you see these three together, pain, wave, and waste, this is likely to be a good problem for you to solve using your innovative capabilities. Which takes me to the next question now, what is innovation? Innovation is not just ideation. While I think Geeta ma'am already emphasized that point, there is much more to innovation than just coming up with an idea. The whole chain of innovation is important. It starts with identifying a problem to solve, maybe reflecting the principles I just shared with you, then coming up with a new idea to solve that problem. That's where the novelty and creativity comes in. But after that, there's a lot of experimentation. You've got to figure out whether your idea works. If not, it might need refinement. It might need combination with other ideas. And finally, you would have to see whether it works through a series of experiments that you do. So in fact, the third important dimension of innovation is experimentation, which I've put under this box of execution. And finally, we consider something to be an innovation if it provides utility to some of the users or stakeholders. We want to see some benefit. some outcome. Someone should benefit from this whole ideation process. Only then is the innovation chain complete. So a simple way of thinking of innovation is to say it's applying new ideas to solve problems, resulting in benefits to users, consumers, etc. Now, a next question which naturally arises is what drives innovation? Now, many times we think that maybe creativity is what really matters to innovation. And yes, creativity is certainly important. But I would argue that in addition to creativity, there's one more thing you need to keep in mind, and that's curiosity. The ability to be curious, to wonder why something happens, to search for an explanation, to think there's a better way of solving something. This curiosity is essential to drive the innovation process. So what many of you need to do as intelligent and smart school children is you need to cultivate this curiosity. You need to keep asking questions like why, how, and seek explanations for many of the things you see around you. That's how you will be able to cultivate and sharpen your curiosity. There are other methods as well. Sometimes you could change the environment, go away from the context in which you originally saw the problem. That might give you some new ideas. Maybe you should shift your perspective, use a different lens, look at the problem in a different way. And you also want to build trust and psychological safety. You want to give a very clear message to everyone who's part of the innovation process that it's safe for them to give an idea, that you will not laugh at their idea. Keep this in mind. When one of your friends comes up with an idea to solve a problem, don't laugh at them, encourage them, motivate them, try to help them take that idea forward so that the innovation process can be successfully completed. Let me just give you an example of how it's important to look in different contexts. There is a very famous hospital in London. It's called the Great Ormond Street Hospital for Children. And some years ago, they faced a very serious challenge. The challenge they faced was that sometimes, unfortunately, kids would have to go through serious surgeries. And after a long and difficult operation, the child had to be detached from the tubes and lines and everything in the operating theater, and then wheeled into the intensive care unit and connected to a fresh set of those instruments and so on. At the same time, the care unit had to absorb information from the surgical team. In other words, the doctors who did the operation had to transfer information about the kid who underwent the surgery to the next set of doctors who were in the intensive care unit or in the ward. And one of the things they found was that this process was not happening very smoothly. And unfortunately, as a result, some kids were not recovering from the surgery at all, which was, of course, a very tragic outcome. So one challenge the doctors in the hospital faced was how do we remove this problem? How do we facilitate or help the transfer of the kid from the operating theater to the ICU or ward so that the whole process is smooth and the health of the kid is not adversely affected? So interestingly enough, one of their senior surgeons at the hospital one day was watching television. And you know what he saw on television? He was watching a Formula One race. Some of you might have seen this on TV. It's a motor car race where these cars go round and round taking loops at very high speed. But after every few loops, they come in for what is called a pit stop. A pit stop is a time when they are refueled, any immediate repair is done, sometimes the tires are changed, the windshield is cleaned. There are a whole lot of operations, and these have to happen in a very short time. So if you've ever watched this on TV, you would be amazed at the speed at which they complete this whole pit stop process. So as this surgeon was watching the whole process, he suddenly realized that maybe these guys were very good at doing a complex set of operations in a very short period of time, and then letting the car go ahead back into the racetrack. So when the surgeon started talking to the people in the F1 race, they learned that what they did in F1 is they had a very detailed set of protocols or operating instructions, which essentially enabled them to conduct the pit stop in a very smooth manner. And what they learned is that they needed to create a very similar checklist, which they could use in the hospital to manage the transfer from the operating theater to the ICU as smoothly as possible. So they basically learned that they had to be much more careful about how they went about the whole process so that they reduced the kind of information handover mistakes. So the point I'm trying to make simply to all of you is that you can get inspiration for innovation. You can get ideas, you can get triggers. Your curiosity can be triggered off in the most unlikely situations, but it all depends on your ability to draw an analog or to draw a comparison with some other field, and then maybe you can get ideas from that field, which will help you in the field you are working. So you remember when I started this talk, I started telling you about Dr. V, who founded the Arvind Eye Hospital. So let me go back to the story of Dr. V. You remember he set up Arvind Eye Hospital because he wanted to provide better eye care. And most importantly, he wanted to address the problem of cataract surgeries. So Dr. V got inspiration from, the most unlikely place. I mean, I would never have imagined that Dr. V could get an idea from such a place. This is actually from a fast food restaurant called McDonald's. At that point of time, he happened to be visiting some relatives in the US, and he's visited a McDonald's restaurant. And there he saw the whole assembly line through which the different hamburgers and other products of McDonald's were being served. And then he suddenly got this idea, why can't we do cataract surgery in a similar way through an assembly line kind of operation? So that's what he finally did. He tried to use that logic, that philosophy, to standardize and create an assembly line for cataract surgeries. So the doctor's time was spent much more usefully. A lot of the pre-operation activities were done by paramedical staff. The doctor's skill was used just for the most critical steps in the process. So one doctor now could do 25 to 30 surgeries per day in the same time that the doctor could do maybe just 5 or 6 surgeries earlier. So essentially, as a result of this process, the whole productivity of the cataract surgery grew significantly. And you can imagine the cost came down, right? Because earlier the doctor was able to do only 5 or 6 surgeries a day. Now the doctor was able to do 25 to 30 surgeries a day. So essentially the efficiency has gone up by a factor of almost 5. So you can see that that would obviously bring down the cost. And that enabled Arvind Eye Hospital to do surgeries for many more patients at a much lower cost in a much more successful way. Now, all this time I've been telling you about, how you go about innovation, where are the triggers, but it may be important to pause for a moment to understand why do you need to innovate? Why worry about all this? Why not just let things go on as they are? There are many reasons why innovation is important. Sometimes it's just to meet national needs. In the early years after independence, we did not have good tractors which were suited to Indian conditions. So there was a very interesting innovation that happened at the Central Mechanical Engineering Research Institute in Durgapur, where a gentleman called Mr. Chandra Mohan and his team built what became the Swaraj tractor, which was specially built for Indian farmers. And later on, that became the heart of a company called Punjab Tractors, which is now part of Mahindra & Mahindra, the world's largest tractor manufacturer. Or you could look at another interesting example. Dr. M.K. Ban was a pediatrician at the All India Institute of Medical Sciences. And he realized that one of the challenges or one of the causes of infant mortality was a very nasty virus called the rotavirus. The existing vaccines for rotavirus were quite expensive. So he wanted to figure out, can we make a lower cost vaccine for rotavirus? And that's exactly what he proceeded to do. He managed to isolate the strain of the rotavirus in his lab. Over a process that extended over many years, he worked with multiple agencies and finally with a company called Bharat Biotech to launch the world's lowest cost rotavirus vaccine in 2015. It's called Rotavac. And Rotavac has been very successful in bringing down the incidence of rotavirus among kids and infants in India and has thereby also reduced infant mortality. Or you can look at what's happening in the field of generic drugs, where some of our leading scientists have really done a wonderful job in creating amazing companies which have been the producers of generic drugs for the world. We have illustrious figures like Dr. Anji Reddy, who founded Dr. Reddy's Lab, Dr. Parvinder Singh, who built up Ranbaxy, and Dr. Hamid, who built up Cipla, which enabled India to be the more or less the key source of generic drugs for people across the world. So this is a very important innovation that came as a result of activity by these people and their companies. So much so that the anti-AIDS drug, which was created by Cipla, was the main weapon or the main vehicle which was used to address the AIDS epidemic in Africa. In fact, it could be said that without Cipla's contribution, the AIDS epidemic in Africa would never have been brought under control. And what's also increasingly clear is that in a tech-driven world, if you want to really create value and you want to capture that value, if you want to, for example, be a leader in the electric vehicle space like Tesla, you need to develop technology yourself. That's why today in India, there's a huge emphasis on developing some of the core and key technologies which the country needs in the years ahead. The good news is that modern India has a rich tradition of science, technology, and innovation. Even if you go back more than 100 years, Acharya P.C. Ray founded the Bengal Chemical Works, India's first pharma company, back in 1901. So we've had a rich tradition. Of course, I'm not going back to thousands of years where obviously lots of interesting things were done. But just looking at modern history itself, you can see that there are very significant contributions. Or you look at our very impactful programs like Mangalyaan, where several of our women scientists played a very key role in leading some of the important missions. Or we have had outstanding scientists like Dr. G.N. Ramachandran, who were responsible for creating the first triple helical model for the structure of collagen, which was a very important development as far as the whole area of biology is concerned. So we've had several impactful people and many in the industry as well. For example, there's Dr. Devi Shetty, who has pioneered low cost and safe cardiac surgery in India. And as a result, he has been able to make cardiac surgery accessible to even poor patients who otherwise would not have been able to afford it earlier. If you just look at the more recent innovations, we've had several interesting ones. Vaccines, you're all familiar with Rotavac as well as Covaxin, which was developed during the pandemic to address COVID. There's Aadhaar, which is the world's largest biometric ID system, which has enabled a whole lot of innovations in fintech and payments and many other spaces to be effective. There is the Unified Payment Interface, which has been, again, highly impactful. India has one of the best digital payment systems in the world, which enables us all to make fairly easy and safe transactions, particularly for routine transactions. Or you look at a company like Tejas Networks that builds some of the best optical networking equipment in the world, or even the new innovations in the way we buy and sell things. Just like there's an Amazon or a Flipkart, which all of us might use daily, there is now a government e-marketplace or GEM, which enables the government to make its purchases efficiently and at low cost. And there's innovation happening even in the development space. The government some years ago launched a program called an Aspirational Districts Program, where the idea was to help some of the most backward districts as far as human resource indicators are concerned, develop very effectively. And what they did was, first, they didn't call them backward districts, they called them aspirational districts to very clearly show their potential. They focused on some critical data and indicators to monitor their progress. Through a convergence of central and state schemes and collaboration at various levels, they created healthy competition among the districts. And this data and reward-driven approach has really enabled the improvement of human development indicators across many of these districts in India. And now the aspirational district program is being converted into an aspirational block program because we want to go even more at the micro level to address the problems in different regions. Or if you look at test kits, again, which was a very important innovation during COVID, which enabled us to quickly identify who is suffering from COVID or not. India has also been the source of new chemical entities like saroglitazar, which was developed by a company called Zydus Cadila. And this is supposed to be the first Indian new chemical entity, which has gone all the way to the market. And it has the potential to address a very important condition, which is a combination of lipid and glucose, where what is called diabetic dyslipidemia. And of course, you're all familiar with Mangalyaan, which was a very low cost, first time right space mission, which put India on top as far as the ability to conduct very complex space missions is concerned. We've also seen deep tech health startups, whether it be Trinetra from Forus, which is a product that enables you to screen common eye problems at a low cost, or Niramai, which is a company which makes a low cost, accurate automated portable breast cancer screening tool. And the interesting things about all these companies is that they are using very recent and contemporary methods like artificial intelligence and machine learning as part of their innovation process. This is something many of you youngsters might like to keep in mind, that even the tools for innovation are changing very rapidly. It's no longer just the lab type observations, it's also the ability to use data, artificial intelligence, and machine learning to solve many of the problems that have been around for a long time. This brings me to the last part of my talk, which is to come back to what I started with. How do you become a good innovator? So if you really want to be successful, you want to take on these big problems, you want to address them, what is it you need to do as individuals to become good innovators? So look at this young lady, Ramya Jose. She can be a good inspiration for all of you. She realized that she was having a tough time managing her schedule. She needed to be able to do her exercise every day. And at the same time, she also needed to be able to wash her clothes. So she came up with this pedal-powered washing machine, which enables her to address both at the same time. So this is a kind of just a very cool innovation, which enabled her to manage her own personal challenges in a much more effective way. Or look at this young man, Uday Kumar. Uday Kumar was a student at the Industrial Design Center at IIT Bombay when he participated in a national contest to come up with the symbol for the Indian rupee. And his entry was finally chosen as the successful one. And that is the symbol which has got nationally adopted as the symbol for rupee today. So people like Ramya Jose and Uday Kumar can be our inspiration, can be our role models. How do you build your innovation capability? Well, there are lots of tools you can use. I don't have time in this talk today to go through all of them, but you can all search the internet, or you can ask your teachers. You can find ways of, for example, practicing what is called design thinking. Or you could use a method called systems thinking, which includes options like TRIZ and theory of constraints. Or you could use methods like lateral thinking. There's a whole approach called Edward de Bono's 6 thinking hats. There are a lot of methods which help you enhance your creativity and build your innovation capability. So TRIZ is a very interesting concept because what it basically says is there are only so many ways in which you can solve a problem. So this is developed by some Russian inventors where they identified all the different ways in which a problem can be solved. So in a way, this provides you a checklist or some kind of a starting point for solution of any problem that you are looking at. So what do you need to do to be a good individual innovator? As you might have already guessed, you need to be curious. That's something I told you about right in the beginning. It really helps if you can immerse yourself in the problem or life of users. Spend more time outside your house. Look at around you. See what problems different people are facing, or even within your house. Look at the problems maybe your mother or your father or any of your friends and relatives are facing, and see, are there some good ways in which you can solve these problems? And remember, pain, wave, and waste are good sources of ideas. Learn new methods to release your creativity. I gave you some ideas. TRIZ, design thinking. There's a lot of good content available online, free content, which you can use to develop your innovation capabilities. Focus your creativity on relevant problems. Look around for problems that will make a difference where you can create more impact. Remember that innovation is not only about your ideas, it's also about working with other people and their ideas. So be open to ideas from others and build on your own at the same time. So try to exchange your ideas with your friends, see if you can collaborate to come up with better innovations. Continuously experiment. Remember, an idea, as I underlined right in the beginning, you need to test it out. You need to validate it. So remember, try to look for creative ways of testing or validating your idea. Now, sometimes you'll need help to work on your idea. You need other people to give you resources or other people to spend their time. So you need to be able to tell a good story around your idea. Why is it important? Why is the problem you're solving important? What is the kind of impact you will be able to create? So build a good story around it, creatively communicate, and Seek people who will be willing to champion your idea. Maybe your teacher, maybe your parents, maybe an older relative of yours. Look at somebody who will be able to champion your idea. And finally, last but not the least, there are 4 types of stamina you need to develop. You need to develop curiosity stamina. You need to develop the ability to sustain your curiosity. It's not enough if you're just interested for a few minutes. You need to sustain that if you want to solve the problem. Experimentation stamina. You need to do repeated experiments. Science and innovation is not a one-shot affair. The people who are successful take years. If you look at any of the big ideas which got translated into successful products, the cycle could take as long as 15 to 20 years. So you need to have that kind of stamina. You need communication stamina. You need to keep talking about your idea. Otherwise, people will not know about it. They won't encourage you. They won't motivate you. They won't collaborate with you. Which brings me to the last point. You need collaboration stamina. You need to build connections, networks. You need to be able to work with other people. Otherwise, you will not be able to take your idea forward. Innovation is not a one-person game. It's a game which you succeed in by working with others in teams and collaborating with others. So these are just some of the thoughts I wanted to share with you today as you embark on this very important journey, the journey of the Jigyasa Epic Hackathon. As you come up with a lot of ideas, you get an opportunity to try them out. You visit some of the CSIR labs, you talk to scientists. But just remember, finally, you need to sustain your journey. You need to have stamina to be able to pursue this till the end. So I wish all of you a lot of luck, but a lot of fun, a lot of interesting things to work on. And I also wish you all the best for your rest of your education, as well as the future of your career. So thanks again to CSIR for inviting me to this event, and best wishes for the hackathon. Thank you.
Thank you so much, sir, for your insightful talk, especially giving us the perspectives of innovation and how we can innovate. So if any student comes up with queries, we will let you know. So we will reach out to you. So thank you so much, sir. Now, as Geeta Vani ma'am also said that we are coming up with 2 themes this year. One is One Health and second is Clean and Green Energy. So now we invite Dr. Radha Rangarajan, Director CDRI, to give her lecture about the One Health theme on of the Epic Hackathon. So to brief about ma'am, she did her Bachelor of Science in Biology from Stanford University, Master of Science from University of Michigan, and PhD from Rockefeller University. She was a postdoctoral fellow at the Harvard School of Public Health and has been actively involved in translational research and product development in the public health arena for the last 2 decades. She has been working closely at the interface between academia, startups, and industry. Her experiences span the drug discovery, diagnostics, and medical devices sectors. She is also the co-founder of Vitus Pharma, a drug discovery and development company focused on novel therapies to treat highly resistant infections. In 2020, she took on the role of Chief Technology Officer at HealthCubed, a medical devices company focused on affordable diagnostics. So over to you, ma'am.
Thank you, Raina. It's a pleasure to be here. Thank you, Geeta, for inviting me to be part of this hackathon. And Dr. Krishnan has very beautifully laid out the innovation paradigm for all of you students. So I'll take you in a slightly different direction and talk about some interesting problem statements. I'll take you through some ideas and thoughts about what's happening in the health space, particularly what we call a One Health approach, which is an integrated approach to health in humans, animals, and plants. So I'm going to share my presentation. Bear with me for a second. I'll pull it up. I hope you can see the presentation.
Yes, ma'am. It's visible, ma'am.
Thank you. So Just to remind you, or just to give you a little bit of a brief on where I come from, I'm the director of the Central Drug Research Institute, which is part of the Council of Scientific and Industrial Research. There are 37 labs across the country. CDRI is located in Lucknow. There are actually 4 CSIR labs here in Lucknow. And when you look at the kinds of areas, when you look at the areas of research across the CSIR labs, they span the gamut of disciplines within the sciences, from physical to chemical to biological, engineering, and information sciences. CDRI was founded in 1951. It's a biomedical research institute, and what we work on is research and development of drugs, technologies, process technologies for manufacturing drugs, and diagnostics. So what do we mean by discovery and development of drugs? Well, every time you take a medicine, for whatever disease or condition that you're suffering from, the process by which that particular medicine was discovered and developed and taken to market, that's what we are talking about. So you know that when you're taking a particular drug, that it's been tested, therefore it is efficacious. That means it works and it's safe. Well, who did all of that research? That is scientists who work on drug discovery and development. And that's what we do at CDRI. We also work on diagnostics. So, you know, understanding why or detecting disease, detecting a condition, that is what is covered under diagnostics. I'm sure many of you have experience with diagnostics, blood-based diagnostics, for example, which are very common. And during COVID, of course, there were the swab-based diagnostics for detecting COVID. So R&D into drugs and diagnostics is what we mainly do at CDRI. We have actually developed several drugs all the way to the market. And what we are best known for is a contraceptive pill, which is taken for women, which is taken by women. It's an oral drug, and it prevents women from becoming pregnant. It's very special because it went to market in 1991 and is orally. It is to be taken only once a week by the woman, and gives her protection from becoming pregnant. The other, so this is again a very a really innovative discovery, because it is a non-steroidal. So, you know, when you look at contraceptives, even today, the majority are hormonal contraceptives, which means that they have effects in various tissues in the body. Whereas what we developed is a non-steroidal, non-hormonal pill. And that is why it stands out even 30 years after it went to market. The other drug that we're famous for is an anti-malarial called alpha-beta artemether. This is an artesunate derivative, and it is given by injection for treating very serious malaria, also called cerebral malaria, that can sometimes be fatal. It's sold in over 20 countries. In addition to this, you know, we like all other scientists, we publish papers, we write patents. Patents allow you to disclose your innovation. So this is one of the ways in which innovators get credit. You talk about why your innovation is unique and why it is better than what exists in the market and what its applications are. And if those patents, those applications are found to be truly novel and different from what exists, then a patent is granted. So the innovation ecosystem is fueled by both fundamental research, which results in papers, and also in patents. These are the areas that we work in. So we have infectious diseases as one of our major areas, microbial, viral, and parasitic diseases. Then we work also on non-communicable diseases, such as neurological disorders, you know, the health disorders, cancer, and reproductive health. And there's both basic and translational research. When we talk about translational research, it is to say that whatever basic research exists, how can you convert that into a product or an application or a solution that people can then use? So today's topic for my presentation is One Health. And One Health is hard to define, but let's put it this way. It's an integrated approach, and it means that through this approach, we want to achieve optimal health outcomes, not just for humans, but also for animals, plants, and so on. So the basis for One Health is the recognition that good health in humans is based on or requires us to understand what is happening to the health of animals and plants and how they interact with the environment. So these are all interconnected. This is the basis of a One Health approach. Why are there such interconnections? Well, for many reasons. One is that as the human populations grow and they encroach into more and more natural habitats, we are coming in close contact with animals. In addition to this, there is also very large numbers of animals that are domesticated for food purposes. And then there is climate change, which is resulting in different patterns of bugs across the world. And finally, there is a lot of movement of people, animals, and animal products due to international travel and trade. And all of these result in very deep interactions between human populations, animals, and plants. One Health programs are fairly diverse, and they focus on principally 4 different areas. One is antibiotic-resistant germs. The other is vector-borne diseases, like mosquito-borne diseases, tick-borne diseases, diseases in food animals, and contamination of water. So today I'm going to focus really on antibiotic resistance, which is also the area of my expertise. And it is a very large part of One Health program focus. So most of you have heard of the term antibiotics, I hope. Antibiotics are given to people when they have infections, but they have to be given only when there are bacterial infections, because antibiotics don't work for viral infections. Now, when you look at the history of human civilization, what you realize is that, a good, all the way perhaps until the 1930s or 1940s, life expectancy was fairly low, in the range of 30 to 35 years. But somewhere between 1940 to 1950, we start to see this upswing, increase in human population at rates that are unprecedented and never seen before in history. And why is that happening? One of the reasons is that antibiotics came into existence. You know the story of Alexander Fleming. He discovered penicillin in 1928, and by the 1940s, penicillin was available commercially. So this allowed this really contributed to human beings being able to overcome simple infections which were leading to death. Today, antibiotics are used for a variety of different conditions. The most common are at the bottom of the pyramid: wound infections, urinary tract infections, lung infections, blood infections. Also to treat gonorrhea, and it is used widely in preterm babies, complicated deliveries to prevent infections, then during hip replacements, organ transplantations, and during cancer treatments, when the immune system becomes compromised. So you can say that antibiotics are the bedrock of modern medicine. And when you look at the discovery of antibiotics, there has been a steady progression of there's been a steady progress in antibiotic drug discovery. We look at this period between 1950 to end of 1960, about a 20-year period, as being the golden age of antibiotic drug discovery, because during this time, many classes of antibiotics were discovered. And after that, you see that there's been a very sharp decline in the number of antibiotics that have gone to market. So now it's become a trickle where there are very few antibiotics that are being discovered and developed by the pharmaceutical industry. And the reason for that is really that there is very poor profitability with antibiotics. But that's a different story. That's for another day. what I want you to take away from this is that antibiotic drug discovery and development has been the way in which we have treated or found solutions for infections. But there is another term which you need to know, which is called antimicrobial resistance. So antimicrobial resistance refers to infections, bacterial infections that can no longer be treated with a particular antibiotic. So what happens is that an antibiotic which is given for a particular infection doesn't lead to a favorable outcome, meaning the person doesn't become cured. And therefore, it leads to either a much longer duration of the infection or even sometimes mortality. Now, resistance to antibiotics is almost always inevitable. That means that once you introduce an antibiotic into human use, then antibiotic resistance or resistance, bacteria resistant to that antibiotic will emerge. So if you look at the history of antibiotic development and resistance development, it is typically a span of 10 to 15 years, and in some cases, even less than that, 5 years for resistance development to emerge. Some of the more successful classes like glycopeptides, and this includes an antibiotic called vancomycin, which you may have heard of, had a very long run with resistance emerging many decades after introduction. But for the most part, resistance development happens within 5 to 10 years, which means that we have to continuously develop new antibiotics. However, that hasn't happened. And the Infectious Diseases Society of America in 2010 said that by 2020, 10 new antibiotics need to be discovered and developed, but this target was not achieved, which means that antimicrobial resistance, or AMR, is now a global problem. And when you quantify it, you will be surprised to know that there in 2019, in a large study by the journal Lancet, 1.2 million deaths were found to be due to resistant bacterial infections, and approximately 5 million deaths were associated with resistant bacterial infections, meaning that that was a contributing factor to the death. Now, to give you some perspective on this, the cumulative deaths due to COVID-19 over the last 3 years has been about 6 million. But what we are losing in terms of deaths due to AMR is in that ballpark every year. So this is a silent epidemic, and this needs everybody to pay attention. And I urge you, school children, to think about this AMR problem and how one can actually prevent this further spread of AMR. AMR, or when you look at the bacteria that cause these infections, there are many. I won't go through the list, but some of the most common ones which you need to know about are Staphylococcus aureus, which is a gram-positive bacterium, E. coli, which is gram-negative, Streptococcus pneumoniae, which is gram-positive, Klebsiella, Pseudomonas acinetobacter. So like this, there are bacterial pathogens, the 6 of them that have been classified by the WHO and by the ICMR as being critical, meaning that they are causing a majority of the infections that are not possible to treat. The ICMR, which is the Indian Council of Medical Research, has studied the isolates which are emerging in our Indian hospitals and found that drug resistance is alarmingly high, which means that resistance to last line antibiotics. These are antibiotics that are given to seriously ill people who are, who may succumb to the infection and may not survive. When you look at a class of antibiotics called carbapenems, of which imipenem is one antibiotic, susceptibility dropped from 81% to 66%. That means that 40% of close to 40% of the E. coli isolates were resistant to imipenem, all of which means that doctors have fewer options for treatment. And that means that there is more mortality, more deaths due to resistant infections. So what is fueling AMR? What is fueling AMR is, of course, that as I told you before, with increasing antibiotic usage, resistance is inevitable. And this is what is shown here in this graph. In green is a class of antibiotics called cephalosporins. And as you see, as we go from the year 2000 to 2015, you can see that the number of units per thousand consumed per thousand human beings in India is steadily rising. And that is true for multiple classes of antibiotics, including broad-spectrum penicillins. So as the usage increases, then we have to ask the question: was all of this use really required? Was some of it used unnecessarily or inappropriately? And if so, then that inappropriate use should, is also contributing to resistance, but it should not be, right? So the whole issue of use of antibiotics in humans rests on who really needs the antibiotics, when should antibiotics be given, for how long should antibiotics be given, and when should or should antibiotics be freely available to people to use for conditions where a bacterial pathogen was not identified for the infection. So it's very common for people to get treated for a throat infection with an antibiotic. But what we have found, what researchers have found, is that 70% of these infections were not bacterial infections. So they were inappropriately treated with an antibiotic, and this usage is fueling AMR. So the first question as students you should ask perhaps is, do we know when an antibiotic should be given? Can we be more certain about whom to give antibiotics to, and then reduce this consumption of antibiotics? You can see 12.9 billion pills. This is an estimate, which is an old estimate. This has been increasing, but we are amongst the largest users of antibiotics in the world. So I would be, I would tell you that in addition to usage of antibiotics in humans, what may come as a surprise to you is that antibiotics are also used in animals. And that consumption has now surpassed human consumption. I don't know how many of you know this, but in animals, antibiotics are used for treatment of infections, which makes sense, but they're also used in what is called metaphylaxis, which is that you treat a group of clinically healthy animals with antibiotics to prevent an outbreak. Or prophylactically, prophylaxis, which is that individual animals may be treated with an antibiotic if they are at a risk of being infected. And finally, antibiotics are used for growth promotion, to boost the weight of animals, to increase their feeding, and therefore to increase the amount of meat that is produced by these animals at lower cost. So, the usage of antibiotics in animals for non-treatment purposes bread food industry in the world. Chicken is one of the meats that is most commonly eaten, widely accepted. India is in fact the world's 5th largest meat producer. We produced about 7 million tons in 2015 or 16. 46% of that is poultry meat. And India is also the 3rd largest producer of eggs and the 4th largest chicken producer in the world. So all of this to say that poultry farming is almost, you can think of it as an industrialized process. You can see in this picture, this is what poultry farms look like. The birds are kept in close proximity, they are packed in, and this is the only way to produce chicken meat at low cost. And when this kind of crowding happens, it's inevitable that there would be infections. And that is why there is a huge use of antibiotics in these animals. In livestock, which includes cattle, but also includes goats, sheep, and other non-poultry animals. Again, the numbers are such. India is the world's largest producer of milk, and like I said, 5th largest meat producer. So when cattle are fed with antibiotics, especially for growth promotion, then what happens is that, and these are often at subtherapeutic doses, which leads to the development of resistant bacteria. And therefore, these animals harbor potentially harmful bacteria, which can be passed on. In aquaculture, we've become, so for example, India is a very large exporter of shrimp. And there have been both the EU and the US FDA have increased their inspections of shrimp exports from India because of the use of antibiotics in the feed, which then leaves behind significant antibiotic residues in these animals. And finally, we have effluents from the pharma industry. So you probably know this, that India is a very it's one of the largest producers of drugs, pharmaceuticals. And this includes antibiotics. And when antibiotics are produced, it's inevitable that there is some wastage. And the effluents from these antibiotic manufacturing units are often released into water bodies, leading to contamination of rivers and lakes. Although there are strict regulations about effluent discharge when it comes to, the level of various chemicals, there isn't the same kind of regulation with respect to levels of antibiotic residues in these effluents. In fact, in 2019, the National Green Tribunal found that so they did a study in a very large pharmaceutical belt, which is near Hyderabad, called Patancheru. And there they found that of the 90 bacterial strains that were isolated from the Musi River, which is near these manufacturing units, several were extensively drug resistant, which means that they are becoming drug resistant in the waters due to continuous exposure to the effluent waste. The same thing happens with waste that is released from hospitals, and the sewage is not treated to remove antibiotic residues. And as you know, hospitals use antibiotics to treat patients, and some of that waste, either through the feces, through other, through the disposal of expired drugs and so on, goes into the sewage, which again contaminates water bodies. So all in all, what happens, and I've tried to summarize this in this picture here, is that there is a transfer of resistance genes from microbes to humans. And how does that happen? So in domesticated animals, including pets, antibiotic usage leads to antibiotics in excreta, that is in feces, which then goes into the soil. And in the soil, bacteria that the soil is full of bacteria. These sorts of resistance genes can be transmitted horizontally between soil bacteria, leading to drug resistance in the soil bacteria, which then has a cascading effect. So when plants are grown in such soils, some of this bacteria then shows up on the fresh produce, like vegetables and fruits, which we then purchase and goes in, and fruits, for example, which are eaten without cooking or washing, and if washing is not sufficient, then human beings get exposed to these drug-resistant bacteria, which can colonize their guts. In humans, the same thing happens. Antibiotic usage, excreta, through sewage enters the water bodies. I just talked about also effluents. All of these things contribute to drug-resistant bacteria being, so evolving in the water bodies. This has an effect also on wildlife, which live off these, these water sources. And therefore, you can now imagine that there is a continuous cycle of these sorts of drug-resistant bacteria circulating between animals, humans, wildlife, and plants. And
Ma'am, are you there? I think your video is paused or something. And connection is lost, I guess.
Yeah.
I think we have lost connection with ma'am. She's back. She's back. She's back.
Yeah, I'm so sorry. I don't know what happened, but I'll.
No issues, ma'am. But still,
Yeah. So
there is still network issue.
okay. So I hope you can hear me and you can see the slide. Can you see the slide?
Not yet, ma'am.
Well, now?
Not yet, ma'am.
Raina, is this visible?
No, ma'am. It
Oh.
might be loading, ma'am.
Is it? You can hear me okay?
Yes, ma'am. We can hear you. You want me to share your slides, ma'am?
Let me just now. Can you see?
We can hear you, but we can't see your slides, ma'am.
Hello. Hello.
Okay. No one is able to see the slides. Yeah.
No.
Anyone is able to see the slide?
No.
No, we can't see.
Okay.
No, ma'am, it's not visible. We can hear you, but we can't see your slide.
Okay, I'll try one last time. Otherwise, I'll just continue without the slides.
Ma'am, unshare your slide and then please reshare. Then I think it may come.
I did that. It's still not showing up, right?
Yes, ma'am, it's not showing.
Now it is coming.
Now it's
Can
come.
you see?
Yes,
Okay,
ma'am.
all right. Yeah, so yeah, I was on this slide, and basically I wanted to say that the problem of AMR interconnected, and people have been thinking about it mostly in the context of humans, but it is a very integrated. It's a very integrated cycle, and therefore we need new approaches. And the One Health work is really about resistance in humans, animals, and the environment, and this circularity of it, this tricycle, which we need to think about, and we need to figure out different places in which this cycle can be broken, so that there is not, so that human health and animal health are not impacted. Or that we can deliver optimal human health to optimal health to all. The reason we need to be thinking about AMR now is because if we don't do anything, then deaths due to AMR are going to continue to rise, and it's estimated 50 there might be even as many as 10 million deaths annually due to AMR. And AMR is ultimately not just a medical or a health problem; it is actually about economic growth. So as AMR, if we do not deal with AMR, then ultimately economic growth of the human population, of the globe itself, will start to, and health equities will increase. That means, people who can afford and who cannot afford health care will today. And you animals and humans. So production, we
Your voice is breaking, Radha.
Ma'am,
There's some network issue.
तो मेरा क्रिकेट ही बोलता था अच्छा बात है।
Are you able to hear me now?
Yes, ma'am.
We can hear you now.
Yes,
We can hear you now.
Okay, so yeah, so I was on my last slide. I'll just try and reshare, but if not, then I'll finish off here. I hope you can see it. So, you know, what we are looking for is solutions for preventing the spread of resistance from animals to humans. And in order to do this, we need good tracking and monitoring devices or tests. So as you think about ideas for One Health, think about how we can measure antimicrobial resistance around us. Whether it's water or it's soil or it is, you know, even surfaces of food. How can we measure antibiotic presence in the environment? And then how can we develop diagnostics that can detect resistance genes? You know, how can we do that more rapidly as opposed to current methods which are culture based? That means you have to take the bacteria into a lab and grow them. So how can we detect drug resistance more easily? And how can we restrict the use of antibiotics in humans to those patients who actually need them? That means that, let's say, for example, we have a test which you can do at home. And if you have a throat infection, it tells you, it's a viral infection or it's a bacterial infection. If it's a viral infection, then you don't need antibiotics. So how can we have these kinds of quick tests to figure out whether an antibiotic is needed or not? Or, you know, how can we know that the infection is over and gone and we don't need antibiotics anymore? That could be another thing. How can we reduce our dependence on antibiotics for prophylaxis? You know, for example, very often doctors will say that doesn't appear to be a bacterial infection, but we'll give it to you because you are at risk for a secondary bacterial infection. That means you don't have it right now, but you could develop it very soon. So how can we reduce antibiotic usage in all of these different situations for human health? These are some of the questions that I would like to leave with you to think about and to innovate on and to come up with ideas to help really human populations, not just in India, but across the globe. So thank you very much for your patient listening. I'm sorry about the connectivity issues, but I hope that I was able to convey the major points to you in a way that made sense. Thank you.
Thank you so much, ma'am. Thank you for giving us the overview of One Health domain. Now, as we have our second domain is clean and green energy. So we have with us Dr. Ramanuj Narayan to give us the overview of this domain. So he is the alumni of Magadh University, Bodh Gaya, University of Delhi, NIT Jamshedpur, and IIT ISM Dhanbad, and CSIR IACT, where he has pursued his graduation, post-graduation, post-graduation in technology, and PhD, respectively. His research interest includes coating paints, hyper-branched polymers, polyurethane, nano-functional and hybrid materials, and third-generation solar cells. He joined as director of CSIR IMMT on 1st May 2023. Prior to joining here, he was senior principal scientist and chair Department of Polymers and Function Materials at CSIR Indian Institute of Chemical Technology, that is IICT, Hyderabad. He is also serving as Dean, Chemical Sciences, Academy of Scientific and Innovative Research, ACSIR. Prior to joining CSIR, he has served Asian Cosmos R&D Corporation Limited, Tata Steel Limited, and Tata Autocom Systems Limited at various positions during 2002 to 2008. So over to you, sir.
Yeah. Good afternoon. Are you able to see the slides?
No, sir. Not yet, sir. Yes, sir. Now it's visible.
Yeah. You are able to see, na, Geeta madam?
Yes, please.
Yes, sir, we are able to see it. Please go ahead.
So, very good afternoon. At the outset, thank you, Geeta madam and team Jigyasa of our headquarters, and all the students who have joined from across the country. So just now it is the turn that first you have taken the dose of innovation, that you have become innovative, and then you have become healthy. Now it is the turn to see your energy, that how much energy you have, and what we do mean by clean and green energy. So I will not talk much about that more than class 10 or 12, because I have a firm belief that any technology, whichever comes, that will come from the science of class up to class 12 only. So can we define what energy is? Energy is the ability to do work or heat objects. And you can also understand that energy source is only two, either light or heat. Or you can define that if you go energy is such a big subject, vast subject, but at the same time it is easy also. You can see people talk about nuclear, electrical, chemical, mechanical, gravitational, ionization, and all my dear students will agree, this is in their class 4 to 6, that what forms of energy we have. And if you are going to your unit and dimension class, then all the electric power, electrical energy, electric current, voltage, time slot, electrical resistance, energy loss. And these terms will be used repeatably across that whatever energy generations you are talking about. So then when topic has been given to us, that what do you mean by clean and green energy? Are the energy what we are using that is clean or not clean, or whether it is green or not? So let us understand first, what do you mean by green energy? If you want to become innovative, you should understand the terms used for these technologies. So green energy, it comes from natural resources such as sun, or clean energy which do not release pollutants into the air. And renewable energy is almost synonymous with the green energy sources that constantly being replenished, hydropower, wind power, or solar energy. Then what is the difference between green and clean energy? Even in solar, there is a chance that some pollutants will come, but wherever there is no pollutants, when you are talking about net zero, all the students, all the persons might have seen the advertisement throughout, that we talk about sustainable development, clean energy, green energy, climate change, net zero, lot of terminology is there. So young friends, you have to think about the planet, that we are using more and more energy. and requirement of the energy globally is 30 to 33 terabyte in 2030. But we have a concern that 99% of the population across the globe breathe polluted air. But right now, once corrective action has been taken, that some of the energy is being used from the solar, wind, and the other forms of the energy. So 90% of the electricity will come from renewable energy by 2050. But if you are harvesting energy, then you will create 30 million jobs and 4.2 trillion US dollars will be saved in the pollution. So, as told by Dr. Krishnan in the first lecture, be an innovator. My dear young friends, be an observer. Whatever, once you get up in the morning, be observer. Observe in and around things, and you will become a billionaire. That I can tell with a surety. Question yourself that once you observe something, write down, question yourself, and if possible, if it is chemicals and things are available in your school, then experiment it. If it is not also available, our CSIR is present all across the country at 37 places. Contact some of our scientists. They will help you in carrying out the experiment and realize your idea. So when we were talking about green energy, so if you'll see whole team, if you are going to Google, use Google wisely. We do also use, you also use, but use Google with a purpose. So now if you think about green energy, solar power, wind power, hydroelectric energy, geothermal energy, bioenergy. Source is what? Sun, wind, water, the earth, and biomass. What is the common in this source? The common in this source, it is all natural. Then whatever science has been done so far, it has been based on the nature, and you also have to think the nature. And if you are thinking in natural way, if you are observing in natural way, then definitely you are going to save our planet. Friends, if you are going to wind power, how many you might have seen the wind power? It will be both in the sea and off the sea. Because off the sea, the problem is that wind may not be continuous throughout, but if you are putting inside the shore, wind will be continuous. The common science everywhere, whether you are going for wind power or hydroelectric power, where water falls or water flow, the common phenomena is the turbine. And you might have seen the Shah Rukh Khan cinema, that how he has generated the energy from the water. The fundamental is very clear. If you will also see your physics classes, dynamo and the cycle, that how it moves in a similar phenomenon, you have to think that turbine is the core. And if you are thinking for solar power, very easily, all of you might have studied in your class 8 what is the photoelectric effect. And then photoelectric effect, you can create solar cell. Only you have to select material. And bioenergy, that how to use energy. All of you are using energy from the biomass in a form of the heat, but how it can be used further, that is the crux of the technology. So as per my understanding, I am also not a physicist that I can explain you series connection, parallel connection, left connection, right connection. But as an understanding, if you want to work on solar cell, that photon in and electron out, that is the only concept. And all of you might have studied in your class lesson that the photoelectric effect is the emission of photoelectrons from a material, matter, and electromagnetic radiation hits its surface. And then it will give you three phenomena. One phenomenon is photovoltaic effect, what is used for solar cell, then photo emission, this is for other purpose, and photoconduction. So different forms is created, but the core is HNU. And that's why in the downside, solar cell, how it looks like, but common that we harvest the light. Hnu will fall onto the body, electron will come, and if you will become a physicist, then physicists will talk when a molecule material absorb photon, then there will be a generation of charge and carrier and charge collection and recombination. And all of you have studied in your physics lesson that what is PN junction, what is N-type semiconductor, what is P-type semiconductor, and what junction it separates. So fundamentally, if you want to create any solar cell, you have to generate electron-rich molecule. How hole is created, how electron and hole are getting separated. Then over the years, we are not the first to talk. CSIR is not first to talk. Globally, since its inception over the years, lot of technology has come on. Kids, my dear young friends, multiple technology has come. One is the cells based on the silicon solar cell. Second, in different type of silicon will be used. Then second is the second and sixth compound that is called thin film solar cell. And the latest what our CSIR has put lot of effort is the excitonic solar cell. So that you should also know that CSIR was the first in the country to start in silicon solar cell way back in 1960s when our lab at Delhi, that where this program is being coordinated, NPL has done substantial amount work on the silicon and thin film photovoltaic. Of late, when Jawaharlal Nehru solar mission has come, almost 12 laboratory of CSIR has worked on the different different solar energy storage, and each aspect of solar cell. So I will take you in little bit detail because we were working with a team at CSIR IICT on dye-sensitized solar cell. And if you'll understand lecture today, you will able to fabricate dye-sensitized solar cell in your classroom itself. So you can see whole world is approaching because solar energy is in abundance. Solar gives two types of energy. One is your light. You can harvest that in called as a solar cell, but that also gives heat and that can go as a solar thermal. And today it is used worldwide wherever, and India is fortunate to have lot of solar energy. So my young friends, innovate in the solar cell area, then you will make our country very proud. So I will be talking about dye-sensitized solar cell. So dye-sensitized solar cell, why CSIR has started working on dye-sensitized solar cell? Why IICT has working on the dye-sensitized solar? Why Karaikudi was working on the dye-sensitized solar cell? And one of the lab of our Nish Trivandrum, if you want to see whatever photographs I will be showing, lot of devices is being fabricated. If you want to develop dye, visit to IICT. If you want to develop electrolyte, visit to Karaikudi. That is the length, knowledge, and breadth of CSIR. So wherever you are, if you want to explore into third generation solar cell, all of you are most welcome to explore with our scientists at different places. If you think about fuel cell, go to NCL, go to Karaikudi, go to CGCRI. So why I was talking dye-sensitized solar cell? Young man, you might have seen all solar cell whatever available in your street that goes with a 37 angle and it will be in a fixed direction. But can you think that solar cell can act vertically with a similar efficiency? All solar that whatever we see that is translucent, but can you think that a solar cell can be transparent, which can become your window? Then can you create your curtain, your dress, your military clothing, your umbrella? That answer will come this type of dye-sensitized, perovskite, and organic photovoltaics. So this advantage is transparency, colorful, that you have shown the colorful. It is flexible. You can put on a hard substrate and you can also put on plastic as well. And it is easy fabrication. As I told you, you can create this type of solar cell in your lab. So less energy will be required because in silicon solar cell manufacture, lot of energy goes down. And most important thing is that there is a rainy day. If our soldiers go on the Himalaya, that place, other solar silicon cell will be very heavy. But if you are using this type of die-sensitized and organic solar cell, it can print it on cloth, it is lightweight, and on rainy day, it outperforms silicon solar cell. So it works under diffuse light. Therefore, in future, your house curtains will be made of die-sensitized solar cell. It also activates inside the light. And if you want to see the device that how it works, you can visit our NIST Trivandrum laboratory. Very simple to fabricate. You have to take two conductive glass plate. One glass plate, you have to put a TiO2 paste. You can cast in your lab with a simple scale and then dip in a solution of dye so that one electrode is ready. Then you have to coat platinum on the other side and then fill the electrolyte, both the cells you bring together and seal it, and your solar cell is ready. It's so simple that to take two glass plates, coat with the dye, coat with the TiO2, absorb the dye, then put the back electrode ready with a coating of platinum, and even you can do with your pencils in your classroom. That will also work, that graphite electrode, and then seal it together and fill the electrolyte. You will get the ready. Why this is so important? Why it was working like this? So once again, it is a class 6 problem that it works on the principle of photosynthesis, how photosynthesis dye is used. All of you might have seen, and that's why all our CSIR IICT team at CSIR IICT is working on the development of various types of colorful dye. Some of them I will show you. So it is nothing but a replica of photosynthesis. That's why, friends, I told you that you have to observe the nature. And Michael Gretzel was first to observe into this type of phenomenon and this photosynthesis. Same type of devices can use for water electrolysis as well, only changing the material. Therefore, my dear young friends, materials is the key. Materials control the function. You understand periodic table, you understand little bit of organic chemistry, and no technology is beyond that. And so what we can do, TiO2, dye, and electrolyte is the three part. Then once you will think that why I'm talking, what challenge I am throwing, that our technology is best right on gel electrolyte and the liquid electrolyte. If you want to make it durable, dye-sensitized solar cell is as efficient as silicon solar cell, but durability is less. So the challenge for you, for your generation, is to how to make a solid state dye-sensitized solar cell, and the world is progressing into that direction. TiO2, as you understand that whatever PN junction, P-type semiconductor, N-type semiconductors you are talking about, but TiO2 as per the band gap theory is an insulator. Then what happens? That's why, my friends, nano comes here. If you are taking nano TiO2 and if it is absorbed with the dye, it becomes a semiconductor. This is the reality of the nanomaterials, that how it changes based on this the shape, size, and distribution. So you have to make it a paste. Then process I will tell you. Then dye. Which type of dye will work? Now UV will degrade the dye. IR at the top end will burn the dye. So whatever dye, we have to develop a broad absorption dye, which can work, which will absorb the light, and that will eject the electron, and then electrolyte will complete the cycle. So we have to develop a good redox electrolyte, and people are working across in CSIR, not only in CSIR, across the globe, how to improve the durability of this type of solar cell. These are the dyes which our friends at CSIR IICT has made, scaled it up, and it is nothing but a ruthenium complex, because ruthenium complex, because this place you have to do anchoring, absorption, and even in paint pigment it is used phthalocyanine. It is insoluble, but IICT made it a first time a soluble phthalocyanine and porphyrin dyes, which is being, I will not bore you with much structures, but our scientists have put lot of effort on the development of different dyes, and CSIR has championing the cause. If you want to make dye for solar cell, if you want to make dye for paint, if you want to make dye for lipstick, if you dye for anything, that type of expertise is available to CSIR. Even in your lab, you can take a flower and you can extract a small droplet of dye that will also give you dye solar cell. Only you have to buy TiO2 paste. So it is eco-friendly. You can create in your lab, take two conducting glass plate, and these are the phthalocyanine dyes what we made at our laboratory. So you can see these are the structures. Don't feel bother about a structure. A structure will come only from 5 elements. Only once we are studying in MSc, PhD, so we make our life complex with a small reactions. We make bigger molecules, and that bigger molecule give happiness and energy to the people. If you want to make bigger molecules, if you want to make dye, if you want to make drug molecule, visit CSIR different laboratory. That is the power of CSIR. We can create molecules from a small monomers and a small entity and reactions. So lot of metallic dyes, organic dyes has been developed, and then these are the electrolytes that I told you in the beginning, that liquid electrolyte, then gel electrolyte. Now this is your challenge to make it a polymer electrolyte or organic whole conductor or inorganic whole conductor. That day you will get a durable dye-sensitized solar cell which will match the performance of the world and which will match the requirement of the people. That I will show you some of the pictures, and this is the simple schematic what I told. TiO2, sinter, heat it, the organic material will go away, counter electrode, electrolyte, sealant, and that cell that you can see. So this is a simple lab experiment you can carry out. But my friends, you are young, have a caution that whatever you are using a chemical, use the proper safety norms, read the MSDS. If you are not able to get, ask your teacher how to handle chemical well. That's why if you want to become innovative, you should also be safe in the practice. And that's why we are talking about clean and green energy. Now, these are some of the pictures you saw that we used to work with Japanese company. We were having collaboration, and now see that whatever I was talking about, that you can see in the reality that where dye-sensitized solar cell, how it is being made. It has come to the module level. You can create walls out of it. You will create curtains out of you can create the solar cell silicon type of model. And this is a Toyota dream house which has been built with the technology of the dye based on the Z907 and black dye. And then you can create artifacts. And the major thing that tomorrow, can you think that this will become your rooftop of the car, different type of ornamental design? It can be printed on plastic, so it will become flexible. So you can create a leaf. Since we have started with photosynthesis, it can go to leaf also. So these are the leaf phenomenon. That's what I wanted to show you. So you can see this will go on your school bags also. You can charge your mobile, you can hot your water, everything by using this. And you can understand that how it is going to be in future rooftop of the car. And this is the mobile and purse, that whatever I am showing, these are the reality. Google is wise enough to give us all the pictures. Our collaborators have provided us the picture. So then in introduction, madam has told that I'm a paint technologist. I always see everything as a paint. Can create a solar paint? That is the challenge to you, my dear young friends. So paint is made of 4 materials. One is a polymer, one is a binder, one is a pigment, and another is a solvent. And when I was comparing, so whatever dyes they are using, pigment they are using, it is very similar. Whatever filler I am using, very similar. So future is very bright. The dye-sensitized solar cell or perovskite solar cell. And if you search Google, lot of things will come, lot of challenges is there. And this you can easily mix and coat it. And if you have a multimeter in your lab and with a simple electrochemical measurement unit, you can create a solar cell in your laboratory without having much harm. So this I am not talking in air. So these are the news what I collected for you, that solar paint is going to knock your door. The first paper has come from the US, that is the sun believable solar paint, where they have used the disensitized solar cell concept with cadmium sulfide and cadmium selenide nanoparticle to create a yellow color solar paint. Similar was our friends at IICT has developed a solar paints using similar type of phenomenon on a zinc type of substrate. So you have enough opportunity, young friends. We have explored. You read these literatures and try to come. And if you want to work on solar paint, please visit CSIR IICT. So there is a lot of challenges, but if you will not accept the challenge, how you are going to contribute into clean and green energy. So tomorrow you paint your house. When you will become a billionaire, you can become an entrepreneur, and these are the things, that area that where you will think, and all materials are available in India, so you can create a house painted with solar cell. So solar paints is one of the future beside other things, so explore into that. Second thing, what I will be talking about, that everybody, that all of you have studied in your periodic table, the hydrogen. This is the future fuel, and today people are talking about, even our honorable minister was showing that hydrogen car is the reality. That's why if you want to make a clean energy, green energy, hydrogen is the fuel what people are looking for. Once again, it is a class 6-7 reaction. Please search Google, try to see how many organic reactions evolve hydrogen, how many inorganic reactions evolve hydrogen. Very simple reactions, and that will be joined hand with engineers to make it a solar cell. And we are proud to tell you that our CSIR is the first to produce a hydrogen fuel cell bus, where fuel cell has been used for the green vehicle and with a KPIT International Technologies, and that place major CSIR NCL, CSIR Karaikudi, and in some part CGCRI was involved into the fuel cell development, which has powered the bus and future all the bus. Today you might have heard about CNG bus, but tomorrow you will be getting fuel cell bus, and then in future when you will work very good, so all bus will be painted with solar cell. At least light fine air condition can run through solar paints. So hydrogen. Now hydrogen only one element in periodic table. Now right now whatever we are using, that is the black hydrogen or brown hydrogen, whatever you tell, because it is used from coal, that is black. But today, tomorrow, it is right now people are working on gray hydrogen, blue hydrogen, turquoise hydrogen, and green hydrogen. So a lot of development has taken place. Processes, steam methane reforming or gasification will give you gasification, because hydrogen is generated with CO2. That's why it is called gray hydrogen. Once again, blue hydrogen, steam methane reforming, and with carbon capture facility. Once again, hydrogen is generated with carbon dioxide, but a reduced carbon dioxide. And then turquoise hydrogen, where carbon dioxide is captured. So you are getting hydrogen plus sea solid. This means it is very near to green, but people are working on the electrolysis. Once again, a 7th class solution, that you have read Faraday law of electrolysis, electrolysis of water, and you also remember the small reactions of the how electrolyte works in your 3 Idiots movie. You have seen the sodium chloride, that which type of electrolyte. Everything is moving under electrochemistry, my dear friend. If you understand the half cell reaction, if you understand corrosion, if you understand the half cell reaction, you will understand the electrolysis. You can generate hydrogen, you can create batteries. So fundamentally same. So all of you should study your book. My friends, don't depend on only the books, what is available this on internet. Please read textbook that whatever is prescribed to you, and whatever is in that book, try to practice it. Do the self-doing exercise. What is within your reach? If it is not in your reach, come to CSIR. So electrolysis, simple reaction. All of you do. If you go on 9th class, if practical will be there, only 2 half cell reaction. One will be cathode, one will be anode. And whole world is working on this, whether you want to electrolysis or battery or water, only material will be changing. Electrode material will be changing. Electrolyte will be changing. Catalyst will be changing. So whole world is looking for your innovations in the electrolysis, and you study Faraday electrolysis better than me. You understand electricity law better than me. Faraday's second law of electrolysis, and this has to be translated if planet has to become green and neat. Simple electrolysis reaction. I don't want to bore once again. I collected that how you will do a exercise. I have done this exercise for you, that the future fuel hydrogen from water, if it is a feedstock, how it is created. It is by electrolysis, electrophotolysis, photolysis, thermolysis, and chemolysis. If we take monthly one exercise like this, India will be the green power country. Similar, if I will take water plus biomass, it will be biolysis. If I will take brine, proton exchange membrane, and biomass, once again, these are the collections, what I did for you, exercise for you. In a similar way, you try to create in how many ways hydrogen can be generated. In how many ways we can use the organic reactions too. So these are the questions should come to your mind, then you will become innovative. Similarly, we can use from coal, and today we are talking about bioenergy, that how microorganism is going to use it, how microalgae is going to use that. So hydrocarbons is used. Once you will observe your nature, if you see lot of water will come on your wall, then green type of patina will come. Can that microalgae will be used? That's why I told, become a good observer. So if you have created a problem, but nature is kind enough to provide you solution, to provide you microbe, try to understand that. And latest report is there that seawater, if I will use water electrolysis, water is also limited, but seawater is having little bit more. So this is the latest report where how you can use directly hydrogen from the seawater. That is the challenge in students. Wherever your house is nearby sea, bring some salt water, or you can create salt water in your home. If simple sodium chloride will give you some type of flavor of sea, but if you make different type of carbonate, strontium, so you can create seawater in your home also, in your school also, and you can do the hydrogen bubble reaction with a 2 electrode, you will be getting your class 10 plus 2. Then once we are generating energy, then major problem, why hydrogen is not popular? Because storage is a problem. Once again, your class 7 problem, that half cell reaction you remember, electrode and cathode, and then storing energy, that how many types of battery? All the battery, whatever I have shown in the picture, you might have seen from your class 2 level only. So always try to understand, read what is written on the battery, whether it is an alkaline battery, whether it is a lithium battery, and what is a lithium polymer battery or nickel metal hydride battery. Read whatever is instructions given on the battery. Then if you understand, then simple. Once again, I told you electrolysis, I have seen the same thing. Oxidized metal electrode. Once again, whole world is moving on cathode and anode. Sometimes you can use for electrolysis. Sometimes you can make it for the battery purpose. So my friends, study the electrochemistry well. And CSIR is proud to have the first laboratory in the country, which is named in Central Electrochemical Research Institute. And do you know, it was established in when? 1950. You can understand the visionaries when they think about energy, and today we are expanding. So once again, I collected for you. There will be 2 types of battery. One is a primary battery. Then you can also go to reaction mechanism, reversible irreversible reaction. Primary batteries cannot be recharged. One time it has converted into energy, then it is irreversible. And then rechargeable battery. Whole world is looking for lithium battery or aluminum battery or rechargeable battery because you want to use again and again. Why this difference? Because if it is primary battery, you have to think that lot of waste will be generated. Then also you have to think efforts into how to recycle that, how to reuse, because materials is limited, energy is limited. Nobody can create energy, nobody can destroy energy, but you can only store energy. So this is the secondary rechargeable battery when this reaction is reversible. And that's why our friends will test it, but how many charge discharge cycle, and that determines the lifetime of battery. And once again, physicists will think this is series connection, parallel connection, vertical, top, down. So you try to understand and collect the information like you will become innovative. And just I told you, painting the wall. Now, tomorrow, your mobile will become simple paper because people are thinking, and even they are printing the printable battery. Same thing can be come onto the plastic substrate. Same thing can be printed on paper. So these are the thinking, that is the challenges what I am throwing to you. And visit CSIR different labs, dear friends, you will able to do many things here. Then another term what I want to tell you, syngas is the powerhouse. Syngas not only give hydrogen, but that will give India self-reliance in chemical as well. So it gives that if you make a syngas, then it will give you char. Char is going to be used in the steel making. That syngas, if you are put under the control burning, then hydrogen, CO, CO2, and the challenge for you, if anybody who are interested in chemistry, how to convert chemicals from the CO2, how to absorb CO2. So these type of phenomenon, this is only for your concept that in future, once you are thinking, you should always look for syngas. Then clean energy. One people will take carbon sequestration. Once again, I request you, become a good observer. If any factory will come out, they will put plant. So that is called natural sink. Therefore, those are the carbon sink. Water body, plants, grasslands, soils, oceans, and anything that will absorb water. But it doesn't mean that you put lot of smoke, lot of CO2 into the air. So there is a limit. It should be emitted within limit. If you are making a factory, if you are making these things, so if you are putting one pillar, you have to plant 10 trees, then also greenhouse will come. And then chemist has to try to convert that into chemical. Then another thing is geological. Rock also absorb. So that's why don't break the rock. They will also absorb. They will give, even if you think of graphene, everybody talk about graphene nanomaterial. Graphene can be produced from CO2. How to put them? Then lot of engineering molecules. And once again, ionic liquid is going to come in the future. And even brine or salt water is going to be a good thing. So how to use the nature for the sequestration, that is the challenge. That is the thinking you have to go. Now, I will give you a homework to all of you. Can you categorize the plant, that which type of absorption happens, how it will be transported? In that plant, you study in class 4, that whenever you make a small plant, that if you are putting in a soil, whether it is reaching silica or not, similar experiment has to be carried out. Which plant absorbs CO2, which absorb plant CO, and those type of plant has to be classified and placed into that place. So how you are going to help your younger generation? You might not having all the equipment for experiment, not chemical, but a small learning. If we are living right, if we are understanding right, you can also help in carbon intensity reduction. So tell your parents, or you use energy efficient appliances. Energy saving is also important rather than energy harvesting. Replace older appliances, fridge and other things which are not energy efficient. Reduce the use of air conditioning. Make sure your home is well insulated. Then you don't require air conditioner. You put a natural insulation. Use LED bulbs or energy saving bulbs that you see in advertisement, 5-star bulbs. So those type of phenomena. Adjust your thermostat to conserve energy. So these are the small things, renewable sources of energy. Tell your parents, tell your village man why we are not using solar cell for the street lighting. Why not we are using for these type of a small observation? When a students like you suggest to your parents, parent will definitely bring the solar cell into their home or into their farm. So responsibility lies on you. And use the carpool. Tell one mohalla should buy an electric car or hydrogen fuel car. This is your periodic table. All of you study periodic table, and everybody is talking, crying that lithium is less. But why lithium is less? Why it is not found across the globe? So nature has limit. They cannot give everything free like air. You understood the importance of air during Corona, that tomorrow you will understand also nitrogen. So tomorrow you have to understand hydrogen also. So every element has to be used. Waste has to be used as a resource. That there is nothing like a waste. You remember, if you go to your native place in villages, people used to put garbage, and garbage used to generate methane gas. And today we scientists claim that it is a biogas. Biogas is created in your home. It is created in the a small debris that whatever you do. So all those reactions has to be observed on the everyday basis. This is the periodic table of future, my friend, that we people, including me, has used periodic table like left and right. But these are the periodic table. Whatever you see in green, hydrogen is in plenty, nitrogen is in plenty, oxygen is in plenty, sodium in plenty. That's why lithium battery is going towards sodium battery. They are going towards aluminum because aluminum is plenty. Then this type of battery concept will come. Can lithium battery will become sodium, aluminum, magnesium, like that, potassium battery, zinc battery, that battery. These are the problem which is for you. Then only one thing you remember, these are the material. Become smart, be a specific, timely, realistic, measurable and acceptable, and raw materials control the function. What electrode you will take, what metal you will take, and this is the interface gives the solution. Therefore, read about material, use Indian material, that will give self-reliant. And if you want to become very smart, these are the prescription. You should remember your class 6 to class 12, whatever I have written. This will give you coating. This will give you energy devices. This will give you sensor. This will give you everything. So these are the phenomena: conductive, color shifting, corrosion sensing, light sensing, optically active, and if you'll understand acid-base titration, complexation, bond formation and breaking, electrochemical reaction, photochemical reaction, whole technology is lies into this chemistry only. Nothing else is required. So India drivers, our Honorable Prime Minister, President of CSIR, is looking for Empower India. Our Jigyasa has brought you those. If you want to explore into solar energy, wind energy, where you should visit. So way forward is nature is the biggest enabler. Be an observer of nature. Try to do natural thing, how to use nature wisely without making a harm. Don't let Mother Nature become once upon a time. We have to replenish. For that, use green chemistry, greening concept, clean transport, water conservation, green building, energy efficient lighting, innovate in renewable energy, hydrogen, waste to energy, energy storage, combine heat and power system, you will get the solution. Practice waste management. Nothing is a waste. Everything is a source. Waste as a resource. practice recycling, water treatment, forest management, and become a monitor. Take a homework for your house that how many units are getting consumed, where our mother, our parents are using the things right or not, how much consumption you have done in summer, how much in winter, and what can be solved, and then go to Amazon or any website and try to solve. This type of a small or small observation will make our India clean and green. So clean and green energy future, when we are handing it over to you, my young friends, it will be the world, will be known. Today we are taking that we are in an era of computer IT. Tomorrow we will be era of electrochemical. It will be nano electrochemical and it will be bio nano electrochemical. Be ready to accept this to device and please follow. Jigyasa has come. We have been serving the school students through lab visits, through education, through projects across. And if you want to experiment in biology, visit our biological sciences. If you want to experiment in chemistry, do in chemical sciences. If you want to experiment in engineering, what lab I belong to. If you want to experiment in rock, then you visit IMMT. And then information sciences, visit our Delhi lab. If you want to measure anything, you want to understand physical sciences, CSIR, if you want to realize your dream, if you want to really translate your concept, visit your nearest laboratory. We provide solution on each and every aspect. That is CSIR India. It is a powerhouse for realizing your idea and observation. And Jigyasa is a platform to connect you to CSIR. So thank you very much.
Thank you, sir. Thank you so much. You actually given us a student-friendly lecture on clean and green energy. Thank you so much, sir, for this. Now, to end up the session, I would like to call upon Mr. K. Sridhar, Principal Scientist and Scientist in Charge, Jigyasa, to deliver the vote of thanks. Sir.
Yeah, thank you, Raina. So first of all, on behalf of CSIR Jigyasa team, first and foremost, I thank Professor Rishikesha T. Krishnan for launching CSIR Jigyasa Epic Hackathon and delivering keynote address. Professor Krishnan is a renowned author on innovation, and he has given us an encapsulating talk on innovation and provided a food for thought to everyone. Sir, your talk on identifying right problem, what is innovation, what drives innovation, with examples was very insightful. I'm pretty sure students who have joined us across India would have benefited from your talk. I also thank our CSIR Director, Dr. Radha Rangarajan, Director CSIR CDRI, for delivering talk on One Health. She has identified the broad areas like antibiotic drug discovery that will be helpful to the students. I also thank our beloved Director Dr. Ramanujam sir, Director CSIR IMMT, for delivering talk on clean and green energy. His talk on pollution requiring corrective action, solar and green energy overview, and how to identify research problem, and also connecting it with Jigyasa program and what CSIR can offer is very helpful for school children. And I believe that school students can come out with very new ideas in all this domain. I also thank Dr. Sanjeev ji and Dr. Devidas Di for coordinating with directors for this talk and also inviting school children. I believe it is important for me to thank my CSIR Jigyasa Epic Core Committee team, who are responsible in articulating the entire program and developing this entire, the launch and all the aspects of the screen, the themes and the respective writers. In particular, I would like to thank Dr. Parthasarthi, Principal Scientist from CSIR IITR, for sharing the blueprint of the EPIC program that he has been implementing at CSIR IITR from 2017. We believe that the CSIR IITR program, with this launch, we want to take it from local to national. I also thank our Jigyasa Nodal for taking this event to the school children. Many CSI laboratories had invited school children to their labs. Thank you very much for organizing an event and making this a success. I thank our key stakeholders, all the school children and teachers who have joined us at various laboratories and online for this launch function. More than 200 students have joined physically across CSIR laboratories. They have come to our laboratories and they have been witnessing this launch program. And also we had more than 250 viewers online on our YouTube channel. So we believe this launch has ignited the innovative spirit and expect many more of you to submit new ideas. I thank Head HRDG Dr. Geetavani ma'am for steering the entire event and providing us with the vision and direction. I thank IIT Bombay team for developing the online system for managing the EPIC program online. I thank my team, Mr. Tarun Garg, who has been working behind the screen and managing the entire event online and streaming it online. And also Mrs. Raina Dua for coordinating the entire event and building this program from scratch. Finally, thank you all and wishing you all a very happy new year and all success. Thank you.
Thank you. Thank you.
Thank you, ma'am.